Okay, this is the tough one. This is Unit 3. We're going to start talking probability. There'll be 6 different kind of distributions we'll be looking at. The binomial, Poisson, normal, chi-squared, students t, F distribution. Not really going to go into depth in the presentation. You can't learn it from a PowerPoint, but look at the readings. That's where you're going to see how to use them. First distribution is binomial. And this is discrete. By that we mean we can't have like a fraction. It's either go, no go, pass, fail, heads, tails. You can't have half a head, half a tail on a coin flip. Bi meaning 2, nomial means name. The next one is Poisson. This is another discrete data with more than 2 outcomes. For example, defects per unit, defects on my car, rainy days in a month, ERA in a baseball game. And if you look at the discussion, we're going to figure out how ERA is a Poisson, chips in a windshield, things like that. Discrete with more than 2 outcomes. The normal distribution, this is variable data. By variable, I mean it could be a fraction. So if you ask me how much does my car weigh, oh, a couple thousand pounds, be more exact. 2,100, more exact. 2,120, more exact. 2,122, more exact. 2,122.6, and you can keep on going finer and finer and finer. That's variable data. So some examples: temperature, percent carbon and steel, the age of students in the classroom, the weight of apples at Walmart. Again, we can all divide these to however fine we want, down to the nearest particle. Infinite number of decimal places. The next kind is decision distributions. Now these are basically just a combination of different random variables. And don't get too hung up on that, but you don't find these in the real world. They're strictly mathematical, but they're very useful. In particular, the chi-squared, student t, and F distribution. First one we're going to look at is chi-squared. This is used to compare observed data to expected results, and it's discrete data. For example, I got 2 classes, and they take a test. First class 6 failed, 36 passed. Second class 7 failed, 32 passed. Is the difference I'm seeing a real difference, or is it just random variation? And chi-squared will tell us that. Take a look at equal chi test in Excel, and then look at the readings. And also I got an example of Excel spreadsheet attached to the discussions. But this is chi-squared, discrete data, observed data versus expected. We're going to talk a little bit about student T. This was developed by a guy named Gossett out of the Guinness Brewery. And what it does, it takes 2 sets of data, and this is variable data. Again, we can divide the data, or the data points, finer and finer and finer, infinite number of decimal places. And it tests to see if the means of these 2 sets of data are equal, or if they come from the same population, and if the variation between the sets are just random variation. And you use the equals t test in the Excel function, and take a look at the readings, the video, and also at the Excel spreadsheet attached in the discussions. The F distribution, basically where the t-test was looking at the averages or the means, the F distribution will look at the variance of the 2 sets of data. So it takes it to the next level. This is the underlying theory behind many of these tests. We won't use it directly, but it's the underlying test for ANOVA, chi-squared, binomial. All that comes from the F distribution. Again, I use the flip technique. So as you get into the quiz, you'll see some questions. Give it your best shot, but if you can't get it, don't hesitate to ask me. I think the best way to learn STEM, including statistics, is to see it done a couple times. And I've used those videos at the whiteboard. So if you have troubles, give me a message real quick, and if I think going to the whiteboard will help, I'm there, okay? And here are the links.